Hello, everyone. My name is Faiza Samreen. I'm a computer scientist by background, and my prime research focus is cloud computing and applied machine learning. Currently, I'm working as a senior lecturer at the Department of Computing, Sheffield Hallam University, and hold a partnership with Lancaster University as a visiting researcher. Today, I will be discussing the transformative power of cloud technology and the potential advantages it can provide to environmental science. Computing as a utility is the key concept of cloud computing. Users can have access to on demand computing resources such as computing power, memory, and storage, and they pay for what they use. Users can dynamically scale up to tens, hundreds, and thousands of resources and scale down when not required. Cloud computing allows users to save costs by eliminating startup investments and maintaining in house IT resources. Therefore, users can start a system in no time without needing to pay upfront, and they can easily avoid a situation where they have to pay for the underutilized resources. Cloud computing has revolutionized the way the IT industry's performance in the past. Now, with cloud computing, the IT industry has access to scalable, reliable, resilient, cost effective, and compliance computational resources. Cloud computing is not just limited to renting computational resources. The cloud computing is working hard to empower digital business transformation by designing solutions to integrate new forms of technologies that speed up, automate, and improve businesses such as artificial intelligence, machine learning, big data analytics, and the Internet of Things. Cloud computing is impacting every corner of the business world, including organizations and industries such as education, finance, healthcare, insurance, manufacturing, legal, and many more. However, some industries are at advanced level in using cloud computing and some are behind. This is all about opportunities that one can find. A lot of research initiatives have started to explore the potential of cloud technologies in environmental science, though these efforts are in their infancy. Let's have a look at the exciting opportunities cloud can offer. A large volume of environmental data is collected every day from a variety of sources such as Earth monitoring systems, remote sensors, essential biodiversity variables, satellite imagery, simulated model outputs, etc. This immense amount of data offers a lot of opportunities for environmental data scientists because they can process meaningful information to answer key scientific questions. But this also poses a challenge to store, share, and analyze this data. Cloud technology has the potential to empower scientists to reveal the true power of data by making more effective data informed decisions. Cloud offers various scalable capacities to store a variety of data at a massive scale with an easy to use platform to share and access files. Therefore, it eliminates the need to copy data from one device to another. In addition, cloud based tools offer collaborative platforms to work with different teams, even if they are residing at different places. Once the data is on a cloud platform, it can be shared with lots of environmental scientists, and the same dataset can be evaluated from different aspects by different scientists, hence making the most of the data available. A key point over here is that cloud not only offers a capacity to store big data, but also provides all the necessary platforms and infrastructure to analyze a massive amount of data. A growing number of data scientists are taking advantage of readily installed open source analytics frameworks provided by cloud providers. This kind of attractive infrastructure is easy to use as well as easy to access and can potentially be used for all sorts of data analysis applications. Environmental scientists, in particular, can leverage the benefits without having to worry about installing complex platforms, data accessibility issues, connecting with variety of data stores, writing codes for data cleaning and analysis, computational capacity of their own system, and certainly without having to wait hours to report data findings. Many critical concerns around a model creation, limited capability to run large scale simulations, model calibration, parameter optimization, and calculating the effects of different interventions are considered ongoing challenges for environmental scientists. This can be supported by the computational capacity offered by cloud providers to run multiple large scale simulations in parallel. Model calibration can be done once, and different teams can use the same model to run different experiments and collaborate using cloud platforms. Hence, the same model can be used by many scientific teams to answer different scientific questions. Furthermore, the output of one model can be linked to other models as input, especially if both models and the integrated data sources are accessible via cloud platform. Let's explore a few more possible dimensions where the true potential of cloud can be exploited. By having access to scalable computational power and an analytic services, a flood risk management team can test different mitigation strategies by running multiple large scale simulations in parallel. Or climate scientists can run variations of multiple models to see the implications of climate change. Moreover, biodiversity experts can collect data from sensors and store on a centralized cloud location and apply off the shelf machine learning algorithms to generate meaningful information. Similarly, decision makers can take advantage of these collaborative platforms to make decisions for public health and safety. Let me share with you how we use cloud technology in Models in the Cloud project that was funded in the UK by Engineering and Physical Science Research Council. Through a Models in the Cloud project, we had the opportunity to engage with environmental scientists, and we looked for opportunities where cloud computing could solve some of the challenges scientists and modelers were faced with. We focused on a weather and research forecasting model as a first case study to demonstrate the feasibility of executing models in the cloud environment. We observed that the model is computationally expensive to run, and more complex simulations require access to high performance computing. In addition, a high level of system administration skills are required to install and run this model, making it hard for new modelers to avoid installation errors that can appear due to incorrect system configurations and setup of particular dependencies. Moreover, it was difficult to reproduce results due to variability at the computational configuration level. So, we could see a lot of opportunities for modelers by executing this model in the cloud. The task of migrating weather and research forecasting model to cloud was done in a series of sprints focusing on different aspects of abstraction. All of these experiments were conducted on the Microsoft Azure platform, supported by Microsoft AI for Earth research grant. The resulting framework takes less than 10 minutes to have this model up and running on cloud. Our designed cloud-based framework presents a clear benefit for scientists who do not have access to a high-performance computing facility or do not want to wait in a queue to get their turn. Using this platform, modelers can take advantage of scalable computing resources on cloud to run multiple simulations of this model. A democratized access to the weather and research forecasting model is provided using cloud platform. Therefore, scientists can run simulations on cloud resources from anywhere without worrying about the complex instructions to install and configure this model. It provides them with a collaborative working environment to run experiments on cloud. They can share output data and reproduce results by using computers of the same configurational settings, hence allowing them to concentrate on science. There are clear evidences that moving environmental models to cloud architectures has the potential to revolutionize environmental science via open, collaborative, and integrative approach. It's not just scientists like me, but public cloud providers have also answered the call and are aiming to work hand in hand with environmental scientists. Microsoft's program AI for Earth brings cloud software and AI technology together to empower organizations working to solve global environmental challenges. Recently, Microsoft has also launched the Planetary Computer that offers access to petabytes of environmental monitoring data in analysis ready format to be used by scientists to answer important scientific questions. We can talk about the challenges all day long, but I'm sure you can understand what benefits cloud computing can provide. In order to avail maximum advantages of cloud technology and cloud services, there is a need to build cloud engineering skills and culture in the environmental science domain, with the primary focus that everyone can understand and use modern development practices like cloud technology. This process may not be easy because the structures of the existing models may not necessarily be designed to be compatible with cloud, and these will require redesigning. But the long term benefits are invaluable. I envisage a long term aim to work towards the seamless integration of different models and other technologies like AI, machine learning, and data science techniques to explore interesting aspects of environmental science. I hope I have enlightened you, listeners, to the transformative power of cloud technologies and the remarkable facilities and benefits it can provide to the betterment of mankind and its environment. Thank you very much.